Hello everyone. In today's video, I'm going to show you how to use the kinematics equations to solve different physics problems. Before we start solving the different problems, I want you to see these kinematics equations on the right side. And I want to tell you what this means. The first one is V equals to U plus A times T. V is the final velocity, U is the initial velocity, A is the acceleration, and T is the time. The second one, change in X, which is the change in displacement, U, which is the initial velocity, times T plus half of acceleration in the X direction times T squared. The third one is V square, which is the final velocity square, equals to initial velocity square plus twice of the acceleration in the X direction times change in displacement. And the last one is the average velocity is the total displacement covered by moving particle or object over the total time taken by the object to cover that distance. Okay, so in different problems, you can use these kinematic equations accordingly by manipulating these formulas. You can create a lot of formulas out of these given formulas. However, you need to know a little bit algebra to do so. Let's get started and then show you how exactly we can apply them. Number one, if a car accelerates at a uniform rate of 2 meters per second square, how long will it take to reach the speed of 60 kilometers per hour if started from rest? I always recommend to read the whole statement or the whole problem in full and then try to make sense out of the problem, or try to create a picture in your mind about the situation at hand. Then the other important point is you have to know what is the given, what is required in that problem, and then how can I solve. That means which of these formulas will help me to solve this problem. All right, so according to this problem, a car accelerates means its acceleration at a uniform rate of 2 meters per second square. Meters per second square is the unit of acceleration. So one of my givens is acceleration equals to 2 meters per second square. Okay, how long will it take? How long? This phrase how long is just asking me the time. Okay, how much time is needed. Okay, and then to reach. Okay, this phrase is also very important. It's good to know the phrases in physics so that you can easily sort out the givens. To reach speed of 60 kilometers per hour or a velocity of 60 kilometers per hour. To reach means it's the final speed. Okay, I can tell this is the final speed or the final velocity, which is 60 kilometers per hour. If you reach somewhere, that means you started from somewhere. So if it started from rest, okay, rest means zero. Okay, something at rest is just a zero. So this is 0 meters per second. Now look at this very carefully. The velocity is given in kilometers per hour. Okay, in kilometers per hour. So we have to convert this one into SI unit into meters per second, because my acceleration is meters per second square. I cannot use two different units to solve the same problem. Okay, so I don't want to go the long way to change this kilometers per hour into meters per second. If you find kilometers per hour, in order to change it into meters per second, all you have to do is simply divide that number by 3.6, okay, by 3.6. And then if you divide that by 3.6, it will give you simply the meters per second version of this, which is, for example, 16.67 meters per second. Okay, so this is the one that I'm gonna use in my problem. I already converted the 60 kilometers per hour into meters per second. Okay, if I want to change meters per second back to kilometers per hour, I have to multiply by 3.6. Okay, now if I have this givens, okay, if I have this givens, which formula is appropriate to solve my problem, just to solve t? Well, as you can see from here, the first problem is most appropriate one. Okay, the most appropriate one. So because I have the v, I have the u, the initial velocity, I have the acceleration, and then I can look for t. So out of this all, I have one variable that's not known. So if I have one variable unknown out of all the givens, that means this is appropriate one. Well, I can use different other I can try the other equations, but I just find this one very appropriate for this one. So I know that V is equal to U plus A times T, right? But I'm looking for just T. In order to calculate T, all I have to do is I move this U to the right, to the left side, and then divide both sides by A. So that means out of this equation, I can create another equation. T is equal to, I want you to pause this one and then try to play around if you don't understand this, but I assume you have some algebraic knowledge. So over U times over acceleration. Okay, so you see, from the first kinematic equation, I create another equation that will help me to solve the time given. Okay, so time is equal to, now what is the V? The V is already the 16.67 meters per second, U minus 0, which was at rest 0 meters per second. You divide this by 2 meters per second square. Okay, now, so when you divide 16.67 divided by 2, because this is 0, that will exactly give you 8.3. Now we are talking about time. The unit of time is second. Okay, the unit of time is second, but you can also find the unit from the given units. Okay, this 2 meter per second over meter per second square means, look, meter per second over meters per second square means, what does this mean? Okay, meter per second times, you reverse this one, right? Second square over meter. Meter we cancel with meter, another second with another second, and then I remain with another second. So finally, the unit has to make sense. Everything has to make sense. We cannot blindly write anything when we solve physics problems. Okay. All right, so this is 8.3 meter per second. The car needs 8.3 meter per second to reach 60 kilometers per hour if it starts from rest at a rate of 2 meters per second square acceleration. Okay, good. So let's continue to the next problem. Okay, continue to the next problem. All right, look at this again. Still, don't forget the equations. You might need them. You might write them down somewhere in your paper. So in this problem also, I would read the whole problem first to make sense. So a car starts from rest. Okay, this is one indication also, and accelerates uniformly at 3 meters per second square for 8 seconds. Okay, what happened next? It next maintains the velocity it has reached for 12 seconds. Okay, in the first trip, okay, it reached some velocity and then it maintains that velocity for about 12 seconds. Okay, what happened then? Then it slows down at a steady rate of 2 meters per second square for 4 seconds. Okay, what is the final speed of the car? Okay, now you have to understand the situation first. Okay, the situation first. So that means this car was moving first. Okay, it was speeding up first, speeding up. Okay, it reached at some velocity v. Okay, at some velocity v. Then it continues with this v for some amount of time. Okay, for this interval of time, which is the 12 second. Okay, the 12 second. All right, for 12 seconds. Okay, it reached for 12 seconds. Then something has changed from this. Okay, slow down. The slowdown is like this. Okay, the slowdown was here and then slowing down. Okay, slowing down and slowing down and slowing down. Okay, so you are asked this velocity here at the final. Okay, so all right, so let me do the given first. Okay, the first is acceleration. Okay, the first trip. Remember, I have two trips now. Okay, this is the first trip and then this one is the second trip. Okay, so the first trip acceleration is 3 meters per second square. Okay, for how many? Okay, for t is equal to 8 seconds. All right, for 8 seconds. Well, it started what? It started from rest. Okay, u is equal to 0 meters per second. Remember, this is the first portion of the motion of the car. Okay, then it will reach somewhere from this one. So maintains that velocity, that reach the velocity that's reached from this one, maintains for 12 seconds. Okay, so this 12 seconds is not really doing anything in this problem, but this is just additional information. Okay, so let's find the first part first. Okay, the first part is going to be, now let's call it V, okay, just V1, okay, V1, let's call it V1, okay, the first final velocity of the first trip, okay. Now this is question mark. All right, let me solve it first. So this is gonna be from the given kinematic equations. V is equal to U plus A times T, right? So this V, in fact, let me call it V1. All right, this is V1. All right, so this is 0 meters per second plus, what is the acceleration? The acceleration is 3 meters per second squared times what? 8 seconds, okay, times 8 seconds, 8 seconds. So V1 is now how much? 3 times 8 is 24, right? Second will cancel with second, meters per second. All right, so remember now, this is the first trip. This one is the first trip. And it next maintains the velocity it has reached for 12 seconds. This will be, all right, it starts from 0 and then it reached 24 right here. So it will maintain this 24 all the way 24 for about how many seconds? For 12 seconds, okay, for 12 seconds. So that means I have 24 here for the 12 seconds. Then something will happen out of this one, okay, it will start decreasing. All right, so you are asked the V2, the second velocity. For the second trip now, for how many? Still the acceleration is the same, but this is now, this time it is slowing down, okay. So I'll do this one, I'll call it this V2. V2 is equal to, remember now, V1 minus AT. Look at this. That's why I told you, you need to comprehend, you need to know the situation. You cannot just simply have the equations and then plug in numbers. Look now, when we reach 24, okay, we maintain that 24 for about 12 seconds. That's okay. We just keep going 24 meters per second. And then we're trying to slow down. When we slow down, we are decelerating, okay. When slow down, the velocity and the acceleration have different directions. Even though the velocity is going this way, the acceleration is negative, which is in the opposite direction, okay. Then the initial velocity is not 0 now, because we already reached 24. We maintain that 24 for 12 seconds and then we slow down from 24. So I'm expecting, without calculation, less than 24, okay, the final one. So V2, which is the main final speed here, the final speed of the car, okay, this is now I'm calculating. So V1 is going to be now the 24, okay. So the final velocity of the first trip is going to be used as the initial velocity of the second trip, okay. So that's going to be 24 meters per second. Remember, this was final velocity for the first trip, but now it is initial velocity for the second trip, which is for the final one, okay. Minus, okay, the velocity is still 2. The velocity is 2 now, okay. The velocity is changing now, so that means 2 meters per second square, which is this velocity, okay. This is this 2 velocity, and then the time is how many? 4 seconds, okay, 4 seconds this time. So V2 is equal to 24, right? 24 meters per second minus 2 times 4 is what? 2 times 4 is 8 meters per second. Remember, this second will cancel this second. All right, I have meters per second. The units must make sense, okay. V2 is equal to 24 minus 8 is what? 24 minus 8 is 16 meters per second. Okay, so after all this happened, the car will have 16 meters per second at final, okay, at final. So far so good. All right, I hope you are enjoying the lesson, okay. Okay, let's continue to the third question, okay. So this question is a little bit it needs a little bit critical thinking. So as always, we have to read the whole sentence and make sense out of it first, okay. So let's read it. A motorist makes a trip of 200 miles, okay. For the first 60 miles, she drives at a constant speed of 40 miles an hour, okay. At what constant speed must she drive the remaining distance if her average speed for the total trip is going to be 50 miles an hour, okay. So I will handle this problem by sketching a little bit diagram here, okay, a little bit diagram here. So I must understand that there are 2 trips in here, okay. the first trip is this, okay, and then the second trip is, well, the remaining trip is this one, okay, this one. So the total is 200, but the first is gonna be 60 miles. The first is 60 miles. So let me do this one. Let me call it well, let me use my white pen just to make sure you understand this. This one is 60, right? This is 60 miles an hour. I mean 60 miles distance, and then the remaining, okay, the remaining part is how much? 200 minus 60 is gonna be I will call it x2 is equal to 140 miles. Okay, 140 miles. Okay, very good. Now, so she look at this again. At what constant speed must she drive the remaining distance if her average speed for this is gonna be 50? So this is very important point. Now at the end of the day, the average velocity v average, okay, v average is equal to 50. All right, this is v average 50 miles per hour. Okay, this is 50 miles per hour. So for the first 60, her average speed was, I mean, for constant speed was 40. Okay, so I would say v1, okay, for the first one, for the first trip was 40, right, miles per hour. It's pretty much, you know, slow. So this is just 40 miles an hour. Okay, now at what constant speed must she drive the remaining distance? Which is the remaining distance? This, the blue one. The remaining distance is this 140. Okay, she cannot continue 50 because she needs to have 50 miles an hour on average. So in order to have this average, that means she has to speed up a little bit, right? So it makes sense if she speed up from 40 to something else, something unknown speed, so that she can have 50 at, I mean, at least 50 average, but she cannot continue this one. So I know that now. If I understand the concept, I know I'm expecting the second velocity, which is unknown here, okay, must be greater than 40. Otherwise, I cannot have 50. Okay, good. So you cannot just guess the number here simply to get 50. What number I have to add to 40, and then, you know, because the distance is different, you cannot do that way. So that means I have to know the time taken for the first one and then the time taken for the second one, because the average speed is, look now, the average, b average is equal to what? The average is equal to x total, okay, x total over time total, okay, over the time, the total distance covered by the motorist over total time is going to be the average speed, which is the average speed is known, but I don't know the both times. I know the distance, but I don't know the times. So I could say, all right, this is t1 is just unknown for this one, which I can find it from this both. And then I don't know another t2 here also, how long it's gonna take for this one. Okay, all right, now what I'm gonna do is, because look, this one, the average speed is simply means what? T x1, right, plus x2, which is both, which is 200 over t1 plus t2. Now look, I know everything except this t2. I don't know this t2. I can know t1 simply from this, and then I don't know t2 because I have two unknown variables here. So but what I can do is here now, okay, what I can do is here, I can create an equation for average velocity, okay, for average velocity. So the first step would be this one, okay, v average is equal to the 60, okay, from this one, the 60 plus the 140, which is, I can write it down just simply 200 to make it simple, over, okay, over, right, t1 plus t2, okay, t1 plus t2. But from the first trip, I can have t1, okay, from the first trip, this t1 can be solved simply, okay, that can be solved simply. t1 is equal to what? Okay, that's the 60 over 40, which is distance 1 over velocity 1, okay, because velocity is distance over time, so I can crisscross and then I can get that one. So 60 over, like 60 over v1 is 40, okay, 40, this is miles per hour, and then that's miles, so this is gonna be give me simply 60 divided by 4 is simply 3 over 2 hours, okay, 1.5 hours. So this is 3 over 2 hour, which is the T1. Now, I can rearrange my equation now. So let me come to this one. V average. V average is just the 50, right? The 50 is equal to, all right? Total distance is simply the 200, right? The 200 over T1 is already calculated here. Look at that. This is 3 over 2. 3 over 2 plus T2. I don't know T2. I don't know T2. Okay. So I just can do this parenthesis. Okay. Now, let me cross multiplication. I can cross this one. Okay. Cross multiplication this with this. This is over 1. Okay. So that will be this. 200, right? 200 is this. 50 times the parenthesis. I have to foil the 50 with everything in the parenthesis. 50 times 3 over 2 is equal to 150, I'm sorry, over 2 plus, all right, 50 times T2 is 50 T2. Look at this. This is very important relation. Now, I'm going to solve for T2. If I want to solve for T2, all I have to do is I have to move this 150 over 2. 150 over 2 is 75. I can tell, so I can move it to the left side. All right, so that means 200 minus 75 is equal to 50 T2. Okay, now very close. 200 minus 75 is 125, which is equal to 50 T2. Okay, if I divide both sides by 50, I remain with T2 in the right side, which I can commutative property. I can use commutative property, which is 125 over 50. All right. If I simplify this one, this is simply 5 over 2 hour. Okay, 5 over 2 hour. Now look, now I have both times. Okay, this is 5 over 2 hour for the second trip for this one. So this is equal to, now I can write this one 5 over 2 hour. Remember now, V is asked. What is the velocity for the second trip in order to have the average of 150? So I can do this one now. Okay, V2 is equal to, now what is velocity? Velocity is distance over time. Okay, what distance? The 140, which is the x2 over what is time? The T2. Okay, because you are looking for this V2, you are looking for this one. Okay, so this will give you that 140 miles, of course, right, over T2 is the one that you find it here, 5 over 2 hours. Okay, this is simply, if you rearrange this one, 140 times 2 over 5, reciprocate the denominator. Okay, I hope you know some algebra, so this is going to be 140 times 2 over 5. Okay, after you cancel the units. Okay, this is going to be in miles an hour. Of course, you don't have to cancel any mile per hour. So this is what, 280 over 5, 280 over 5, right? This is simply 280 over 5, which is 280 over 5. Okay, this is equal to V2. Okay, if you simplify this, what is going to be 280 over 5? You can simply use your calculator, which is 56. Okay, which is 56 miles per hour. Okay, this is 56 miles per hour. Look now, let's assess this problem. 56 miles an hour. Well, theoretically it makes sense because she was moving at 40 miles an hour for the 60 miles. So, but she needs to have 50 miles an hour on average for the total trip. So that means she has to speed up a little bit to 56. Otherwise, she's not gonna have the 50 miles an hour as an average of the total, the average velocity of the total distance, or the total trip covered. Now, I can also check this one if I can get 50. I can just check my numbers if I want to. What I can do is like this, check. All right, check. All right, the average velocity 50 must be equal to the total distance, which is the 200, right, over, which is T1 and T2, the 2 times, the total time is 3 over 2, right, 3 over 2, the first time, plus the 5 over 2, guys. Okay, the 5 over 2. Okay, 3 over 2 and 5 over 2. Okay, this is how much? This has to give me 50 is equal to 200. Okay, 3 over 2 plus 5 over 2 is 8, right? 8. Check it. So this means that this will give me again 50 is equal to 50. So this is checked. Okay, this is checked. So I recommend you just to think about this one, to pause and think about this one, because all the mathematical solutions must give or must reflect what's going on in reality according to this problem. So let's continue to the next problem. If you don't understand this, you can just always pause the video, write down, and then you can practice until you understand, and then until it makes sense to you. All right, so let's continue to the next one. All right, to the next one. Here is another also average speed problem again. So as always, what we have to do is we have to read the problem very carefully, and then if we have the same unit, you don't need to bother to change the units into the same unit or whatever like that. But if it's different, make sure to change everything into the same. All right. Now, an aeroplane travels 280 miles an hour south for 3 hours. Okay, for 3 hours. So well, this is the north direction. This is the south direction. Well, this is the east direction, and then this is the west direction. It is good to know. Okay, so that means 280 to south. All right, from this to this, that aeroplane is V. All right, one I can say, which is 280 miles per hour for how much time? Well, for 3 hours. Okay, for 3 hours. Okay, then it changes the direction, and then 250 miles an hour north for 1000 miles. Now remember, so this just changes direction to the south this way. So but this time the distance to the second distance is going to be 1000 miles. Remember, the givens are different. Okay, for the velocity of how much? 250 miles per hour. Okay, so what is the average speed of the total trip? Okay, the average speed of the total trip is asked. Okay, so we know the average speed formula is given by V average is equal to X total over time total, right? Time total. The total time taken for the trip should be calculated. Okay, so what I'm gonna do, well, this is kind of straightforward problem, but I have to know how can I calculate the numbers, my numbers. Okay, so for this one, I have T, and then I have V. So how can I calculate X from the first trip? Okay, because this is what? X, the first trip, plus the second trip over the first time plus the second time. Okay, this is just the formula for average speed. I'm going to calculate the average speed. So let me calculate from the first one, Vt. Vt is given. I can calculate X from this. Okay, I can calculate this X1. Well, remember the relation. The relation is what? The relation is velocity is equal to distance over time. Okay, from this you can play around. So to find X1, you have to calculate V times T. So V, okay, times T. V times T is given here. So X1 from this strip is equal to V is what? 280, right, miles per hour times T is what? Times 3 hours. Okay, times 3 hours. So this X1 is equal to, if you multiply this, the total distance is going to be you can use your calculator, or you just can take 2 minutes to calculate this. This will give you automatically 840. Okay, 840. Okay, 840 miles. Okay, so this is when the plane was heading towards north. Okay, it covers this amount of distance. Okay, this amount of distance. For the second one, well, this displacement is given 1000 miles, and then the velocity is given. So I don't know the time, so I have to calculate the time too. Okay, the time too. So how can I calculate time from this one again? Well, time 2 is equal to x2 over velocity 2. So I'm playing around. If I know the relation velocity is equal to displacement over time, so I can just play around, just moving. If I need t, if I need x, if I need v, just I can just move them around. This is simple algebra. So this is going to be what? T2 is equal to, what is x2? What is x2? X2 is given here. which is 1,000, right? 1,000 miles, right? 1,000 miles divided by v2. v2 is 250 miles per hour. Okay, so the second is 1,000 divided by 250, which is the total time of this one, which is definitely 4 hour. Okay, 4 hour. Now I'm very close to finish my average speed. So that means I have the time here 3 hour. I have the velocity, I mean the time here for the second one. I have the distance for the first one. I have the distance for the first one, and then the second one, of course. So now V average, okay, V average is equal to x1, x2. x1, x2 is what? Here is x1, as I said, 840, which is calculated from that, plus, okay, x2 is what? x2 is 1,000, all right, 1,000 miles over, what is the time? The time taken is, the first one is, where is it? This one is here, 3 hours, okay, 3 hours, plus the second one is 4 hours. So V average is equal to, if you add all this, the top one, 1,840. This will give you 1,840. This is miles, guys. Okay, miles over this is 3 plus 4 is over 7 hours. In 7 hours the aeroplane can cover this amount of miles. So that means the average speed is gonna be, if you divide this one, 262, okay, 0.9 miles, okay, miles per hour, which is okay for an aeroplane to have this kind of speed, I guess. So the main point here is just the average velocity. The average velocity is total distance over total time. All the distances must be added over the total time. So you have to be careful to know what is given for the first trip, what is given for the second trip, and then how can I manipulate those equations together, and then I play around. Okay, so the next one is gonna be about a projectile motion. I will see you in the other video. I don't want just to make a lot of problems at once. I'll just prepare another video for the projectile motion type of problems. I hope you enjoy the videos that I make. So just have a great day.